Okay, this is A2Pure Maths. We're in Unit 6 looking at sequences, and we're just taking a wee look then at the sigma notation, so series and sigma notation. The series u1 plus u2 plus all the way up to u to the n is often written as here. So it means the sum of. This symbol sigma means the sum of the numbers below and above sigma show the lower and upper limits between which the variable is to be summed. Sounds a wee bit complicated, but isn't too bad. Say for example, we have one, there's a nice one down here. This one is between, you can probably see them between 2 and 5. So we got to sub the number 2 into this, then the number 3, then the number 4, then the number 5, and add those values together because this means the sum of. And that's generally then how it works. So this one here is then write down the first 3 terms of the series. So it's going to be the sum of, we put the number 1, it says it starts with 1 and goes all the way up to n, so that kind of goes as far as whatever you want n to be. But let's get then our first term. So our first term, we are going to let r equal to 1. And so it's going to be 4 upon 1 squared, so that's 4, take away 2, and we're calling that u1 obviously, so that's going to give us 2. Second term, we let r equal 2, calling this one then u2. 2 squared gives us 4 times 4 is 16, take away 4, so that one's 12. Third term, r equals 3, u3. 3 squared is 9 times by 4 is 36. Take away 2 3s, so take away the 6, and we end up then with 30. So it's 36, take away 6, we end up then with 30. So therefore this series would be 2 plus 12 plus 30 plus ... Alright. On then to example 2. This is the one we looked at a wee second ago. The sum of 2 to the power of r take away 2r between r equals 2 and 5. So we can just work out those 4 values and work out then from there. So if r equals 2, u of 2, so that's going to be 2 to the power of 2, so that's going to be 4. Take away 2 times 2, which is 4, so that gives us 0. If r equals 3, that's going to give us u3. 2 to the power of 3 is 8. Take away 2 times 3, which is 6, so that gives us 2. R equals 4, so that's u to the 4. 2 to the power of 4 is 16. Take away 8. That gives us 8. And then r equals 5. We have u 5. 2 to the power of 5 is 32. Take away 2 times 5, which is 10. And we end up then with 22. So the sum of this then is going to be 0 plus 2 plus 8 plus 22, and that gives us then 32. Example 3 then, and I'm actually going to change it here. Instead of the r equals 2 at the bottom, I'm going to solve it then for r equals 1, and we'll see what happens. So we effectively need to put the numbers from 1 all the way through up to 16 into this. We're going to do the first few and see if we can come up with a better plan then for doing it. So let's get our first term. So we're going to let r equal 1. So our u of 1, 5 times 1 is 5, take away 1. So that gives us 4. For r equals 2, u of 2, 5 times 2 is 10, take away 1, it could be 9. If I put 3 in there, we're going to get 5 times 3, 15, take away 1, just give us 14. This is an arithmetic progression, so we can work it out using that. So if we write arithmetic series, and what do we know? We know our first term, A, is 4. We know our common difference is 5. There's a gap of 5 each time. And then we want the first 16 terms, so we can just use our sum formula and work that out. So our sum formula for an arithmetic series is n over 2 upon 2a plus n minus 1 upon d. So let's fill in our blanks there. 16 over 2. 2a then, so 2 times 4 is going to be 8. Plus 16 minus 1, so it's 15. Then upon 5. That's 8. 15 times 5, I'm sure I know that, 75. So 75 plus 8 gives us, is it 83? And that gives us then 664. So that's our way then of working that one out. Of course you can just put the numbers in and stick them in your calculator and add them up. There's nothing to stop you doing that. But it's just spotting that that's an arithmetic series. We know our A, our D and our N, and we can find the rest then from there.